So remember when I told you that the transport layer actually moves the information or the messages payload, right, from host to host and not from hop to hop? Well, the network layer actually moves messages from hop to hop or node to node. Okay, so basically the transport layer will be something like figuring out the whole route to send something from source to destination, whereas the network layer only figures out how to get to the next spot and to the next spot and so on. Okay, so the network layer does that. And again, as we saw with the little Russian dolls, it adds its own header and its own layer, right, to the segment, and it puts it inside another doll and sends it down, right? So it encapsulates it and sends it down. And the network layer message, this is very important, is called a packet, because at each different layer, we have a different name. So we said, for example, that the top layers, the top 3 layers, because they kind of merge within one another, we're going to call that the payload. When we talk about the transport layer, then we're talking about a segment, and the network layer is a packet. Okay, so please make a note on that because that's very important. Okay, now every node, every single node that it's on a network, whereas is a cell phone, a computer, Alexa, whatever is on the network is going to have an IP address, okay? And this IP address is going to be unique for every single device on the network. Very, very, very important. The IP addresses are everywhere and everybody has one, okay? So if you don't have an IP address, you cannot use the network. It's like trying to send a letter and expecting to have a reply, but you don't put, you don't have the sender's address. You just have the receiver's address. So how is the receiver gonna know how to send back the reply? So they can't, right? So every node in the network, as I said, has an IP address. IP addresses are everywhere, okay? Now, IP is going to rely on routing protocols to find the best route for a packet. In here, we're going to talk about different routing protocols and how they work, okay? And IP needs to find the best route or the best way to get just to the next hop, right? And as you can see, because this one just goes to the next hop and transport layer has to figure out the whole network, you really guessed, if you think that the transport layer definitely needs to rely on the network layer, because the transport layer is going to say, hey, network layer, can you help me go all the way from here to all the way there, right? So then the network layer is going to say, okay, hold on a second, let me go hop by hop, trying to make a path for you and reserve some resources on the way for you to go from one end to the other end, right? So it goes reserving, IP is doing that, and then it tells TCP, hey, I got your route. And TCP is like, woohoo, now we got a route, right? So they work together. So TCP and IP are the ones that actually build the internet. Most protocols work together. I mean, most things that are sent with those two protocols in mind. TCP and IP working together basically are the glue of the internet, because most of any communication that takes place thanks to those two protocols working together. Okay, so as I said, IP relies on several protocols to find the best route, and ICMP and ARP are some examples. And again, you don't need to memorize those ones right now, but just keep in mind, if you just can remember, put in your mind, and in your head and memorize that ICMP and ARP are examples of layer 3 protocols, then you're good, okay? So the network layer also may divide large packets into smaller packets if they cannot be sent, in the original size. Remember that TCP also will do that, will break into smaller segments. Well, it may break them, to suit the transport layer. But if the network layer says, transport, I know you want this big size, but that's probably not going to work in the route that we're picking to send from one end to the other end. So maybe it needs to chop into even smaller packets. Okay, so and I am saying packets because for IP is a packet, right? And again, for TCP is a segment, and anything above is the payload. Okay, so at the network layer we have these protocols, right? So if you just remember, oh yeah, these are the protocols at layer 3. The one thing that you really need to remember is IP, which is the Internet Protocol, and it rules layer 3. So in here we have this little part, right? That's this little segment or this little piece showing only these 3 protocols, 3 layers, which are the transport layer, the network layer, and the data link layer. We haven't covered the data link just yet right now, right? But we already looked at the transport layer, which is an end-to-end, right? And what it's gonna do, this one is gonna send a segment in here, right? So the network layer is gonna grab that segment and convert it into packet. It will convert it into packet by encapsulating it inside a network packet and adding the corresponding headers, right? Then it's going to add the source and destination to the header, right? And it's going to route those packets, right? And then it will also add a sequence number to each packet. And this may be needed by the transport layer, so when it arrives on the other side, it can be reordered in case anything gets out of order. And that will only happen if the transport layer is using the TCP, because if it's using UDP, then they can be out of order or they may not even get there. Remember, UDP is the rebel one. So now we're going to continue on and we're going to move to the data link layer.